right, number 12. The following diagram shows triangle ABC. It's got all the information on it. Find AC. So we have cosine rule because we don't have an angle on the side across from it. So we're going to have x squared because this is C and this is angle C. Okay. Remember A and B are interchangeable. So we're going to have x squared equals A squared plus B squared, I know, interchangeable, minus 2AB cosine 120. Okay, so if we want cosine 120, I'm just going to start doing this. 120 is over here with a reference angle of 60 degrees. So when we use our hand, 60-degree finger is here, which means that point is -1/2 √3 over 2. Okay? Because this is the 1 and this is the 3 fingers. And we are in the negative x's and the positive y's. Okay? So, yeah. This is 49, 81, and we have 63 times 2, which is 126. Cosine 120 is -1/2. So we are going to have 130 plus 63, which is 193. So we will have plus or minus, but this is a length. So positive √193. There's no perfect squares that go into it. Okay, so if we want BAC, and then obviously, you could do approximate. I just put that in the calculator. It's 13.9, okay? Which makes sense because it should be the longest side across from the largest angle. Okay, BAC here, that's going to be, we can use sine rule now because we have square root 193 over sine 120 equals 9 over sine A. Usually they give you nicer numbers, but sine 120 is √3 over 2, and we have 9 over sine A. So, yeah, we can cross multiply. √193 sine A equals 9 √3 over 2. And when we divide by √193, we're going to have 9 over 2, and then we're going to have 3 over 193. And that's going to be 1 over, does that go into it? No. Okay, so we just sine inverse that whole thing. Sine inverse. Okay. So you get A is 34.1 degrees. All right, 13, a triangle has side lengths 4, 5, 7. Find to the nearest tenth of a degree the size of the largest angle. So we have 4, 5, 7. The largest angles across from the largest side, so we're looking for that. So that makes that little c. And when we're looking for an angle, we can use this one. So we're going to have, remember, A and B. So 4 squared plus 5 squared minus 7 squared. A squared plus B squared minus C squared over 2 times A times B. And you can just put this into the graphing calculator. So C ends up being 101 or 102 degrees. But they want that to the nearest tenth of a degree. So actually it's 101.5 degrees. All right, 14. We've got this triangle. Find the size of the smallest angle. That's here. And then we want the area. So this is C, this is little c. So we're going to have cosine C equals 7 squared plus 8 squared minus 5 squared over 2 times 7 times 8, which ends up being, when you take the inverse cosine, 38.2 degrees. And then for B, we want the area to be 1/2 the two sides times the sine of the included angle. So this times sine of that, which is 38.2 degrees. And the area ends up being 17.3, and this is centimeters squared. All right, 15, we've got a triangle, 5, 4, 6, and this is PRQ. And we have to calculate the size of the angle P. So this is C, this is little c. So cosine C equals 4 squared plus 6 squared minus 5 squared over 2 times 4 times 6. And then for the area, we're going to have 1/2 4 times 6 times sine of that included angle. So C ends up being 55.8 degrees, and we'll do the unrounded here. So the area ends up being 9.92, and we're in centimeters squared. Okay, 16, we have the following diagram, that information, calculate A, B. Okay, so we have sine rule because we can have an angle and the side opposite of it. All right, so 5 over sine A equals x over sine 40, not A, sorry, AT. So you end up getting that x is 3.26 centimeters. And now we need the area of the triangle. So we're going to have 1/2 5 by our 3.26, which is this. And we need sine 60. Okay, so 60 degrees is here. The finger, 60 is here. We're in the first quadrant, so this is cosine 1/2, sine √3 over 2. So yeah, sine, I mean, they'll have nicer numbers, but just to kind of start doing the unit circle. So sine is √3 over 2. So this ends up being about 7.07 centimeters squared. All right, we've got this information. Find P, R, Q. Okay, so we're going to have sine rule. And we're going to have 10 over sine 75 equals 7 over sine R. So be careful here because we are finding, we'll try the ambiguous case, even though they usually kind of clue you in that it is by saying find 2 possible sides or something like that. But yeah, we'll do it anyway. So for R, when you cross multiply and take the sine inverse, you get 42.5. So if we do triangle 1 and 2, we will have the given angle 75 and 42.5. And remember here we do 180 minus that 42.5, which is 137.5. And then we know that each triangle is adding to 180. So we just do 180 minus those. This ends up being 62.5. And when we do 180 minus 75 minus the 137, this gives us a negative 32.5. So this is not a triangle, but this one is. Okay, so I've already found this. This is the 62.5 when rounded. So we're going to have 1/2 7 times 10 times sine unrounded 62.4566. And this area ends up being 31.0 centimeters squared. All right, 18. We've got this triangle, find B, so we're going to have sine rule again. sine, 7 over sine 48 equals 5 over sine B. So we get B is 32 degrees actually, because they want it to the nearest degree. All right, number 19. Diagram below. Oh, and we really should, if we do triangle 1 and triangle 2, we should do 48. 48's given, 32. And when you do 180 minus 32, that gives you the other angle, which is 148. And you know 148 and 48 is going to be over. So this ends up being negative 16 here when we add up to 180. But yeah, the other one's going to work. So there's only one triangle here, and this ends up being 100. All right, 19. We've got diagram show two triangles, both satisfying these conditions. Calculate the size of ACB in triangle 2 and the area in triangle 1. Okay, so AB is 20, AC is 17, and ABC is 50. All right, so we're going to have sine rule here. So we've got 17 over sine 50 equals 20 over sine C. So we get 64.3, but you can see that that's an obtuse angle. So you just need to do 180 minus that, which gives you 115.7 degrees. So that is A. And for B, the area, okay, so we've got 20, 17, see, this is 50. And we found out angle C, that's the 64.3. And we can find out the other angle, which is going to be 180 minus 50 minus the 64.3. So that's 65.7 here. And then we need to do 1/2 AB sine 65.7, unrounded, 10, 17. That ends up being 155 centimeters squared. All right, number 20, town A is 48 kilometers from town B and 32 kilometers from town C. Given that B is 56 from town C, find the size of angle CAB. Okay, this is cosine rule, because we don't have an angle on the side across from it. So we're going to have cosine C equals 32 squared plus 48 squared minus 56 squared over 2 times 32 times 48. So we end up getting that C is 86.4 degrees, or 86 degrees. All right, two boats A and B start moving from the same point P. Boat A moves in a straight line at 20 kilometers per hour. Boat B moves in a straight line at 32 kilometers per hour. The angle between their paths. Okay, so it doesn't really matter. We just need 70 degrees here. Okay, so after 2.5 hours, we're going to have that boat A is 2.5 times 20. And that's 50. And we're going to have that boat B is 32 times 2.5, which is 80. And find the distance between them. So we want this. This is cosine rule because we don't have an angle on the side opposite. So we're going to have x squared equals 50 squared plus 80 squared minus 2 times 50 times 80. That's a 5. This is an 8. Cosine 70. So we end up getting that x is 78.5 kilometers. All right, 22, we've got the following diagram. C is obtuse. AC 5, BC that. Area is that. Okay, so we've got 20 equals 1/2 AB sine C. All right, so we can solve this. So we get C is 36.0, so we need to do 180 minus that, and that ends up being 144 degrees. And now we want AB, so this is going to be cosine rule. So we're going to have x squared equals 5 squared plus 13.6 squared minus 2 times 5 times 13.6 sine of 144, cosine, not sine. And you get x is 17.9 centimeters. All right, 23 in a triangle. We've got all that stuff. So A, B, C, AB is 4, AC is 3. We are going to look for that angle, 2 possible values. So we're going to have A, which is 4.5, equals 1/2 AB sine C. Okay, so we've got 9/12 is sine A, or 3/4. So it's not a special right angle, but whatever. This gives 48.6 degrees, and we just need to do 180 minus that to get 131.4 degrees. Okay, in triangle PQR, so if we draw PQR, we've got PQ's 10, QR's 8, PQR's acute, the area is 20. So we have 20 equals 1/2 AB sine C. So that's 540. So this ends up being 1/2. 20/40 equals sine Q. So when is sine 1/2? We can make sine 1/2 at 30. So that is the answer, because they say it's acute. Okay, there is a vertical tower, TA, of height 36 at the base of the hill. A straight path goes up from the hill to point U. The information, the path makes a 4-degree angle, which means this is 86 degrees. The point U on the path is 25, so that distance is 25 to here from A. The top of the tower is fixed to U by a wire, length X. Complete the diagram, that's that. Find X. Yep, cosine rule. So we're going to have x squared equals 25 squared plus 36 squared minus 2 times 25 times 36 cosine 86. So we get the wire length is 42.4 degrees. All right, diagram below shows triangle. Yep, all this information. Find the size of A. So this is cosine rule. So we're going to have 7 squared plus 7 squared minus 13 squared over 2 times 7, times 7. And CAD, okay. So we get C is 136 degrees. And if we want, okay, so we can do 180 minus that to get this thing, 43.57, blah, blah, blah. And we'll use sine rule here. So we're going to have 6.5 over sine 43.5 equals 7 over sine D, and then we'll do 180 minus that. So we get D is 47.9. We could do triangle 1 and 2, but I don't think we need to here. But anyway, so we do 180 minus those two angles, 47.9 and 43.5. You get that angle A is going to be 88.5 degrees. So I actually just checked triangle 1 and 2. So we've got 43.5, which is okay to use. We didn't find that by sine rule. And then we have, it's actually 43.6. Okay. Then we used sine to find out the 47.9 degrees. And when you do 180 minus 47.9, you get 132. And then when we do 180, so we found this one out to be 88.5 degrees. And then when we do 43, so 180 minus 132 minus 43.6, you do get 4.35 degrees. So we have two possible angles for our answer. So that's the size of angle C80.